This happened to all of us. You start your trip with a perfectly packed suitcase, and when it is time to go home and cram all your clothes in there, all the exact same stuff seems to have magically expanded. It is always harder to get the bag closed on the return trip, and that is because physics is working against you, as it always seems to be, especially during physics class. So naturally, physicists have studied this to figure out the ideal way to fold your clothes and absolutely stuff that carry-on. They didn't actually specifically research carry-ons, but we can apply their findings to packing clothes. And we've squeezed it all into this video on how science says you should pack a suitcase. In the masterpiece that is a well-packed suitcase, each folded t-shirt acts like a single Lego brick. They all fit together because of their shape. But there is, of course, variety among Legos, and just like a Lego's shape determines where you can put it, the way you fold a particular piece of clothing determines where it fits in your bag. And we can use math to figure out what the ideal clothing brick looks like. Starting with a thing called the volume fraction. That's the volume of your shirt divided by the space it occupies after folding or crumpling. And that number gives you an idea of how condensed the shirt is. For example, a flat piece of paper doesn't take up much space. It's just the volume of its fibers. Its volume fraction is 1. But of course, if you crumple up that same piece of paper, it would take up much more space without having any additional material. So its volume fraction is much less than 1. And that is not what you want. So on a scale from 0, you're wasting a lot of space in your bag, to 1, you've perfectly solved the packing puzzle. Here is how different packing techniques measure up. Starting out with the it'll definitely fit crumpling strategy. This is where you just throw all your clothes into the suitcase and smush with all your might. Does this save you time? Absolutely, but I gotta break this to you, you are definitely paying for that second bag fee. See, if you crumple your shirt into a ball, it takes up a deceptively large amount of space. We know this from experiments on crumpled aluminum sheets. The outer section of the crumpled ball might pack in relatively well, forming flat-ish layers that stack on top of each other, and based on all the wrinkles you will find upon unpacking, you might assume that this method is pretty efficient at condensing the shirt into a small volume. But an X-ray view of that crumpled ball reveals that the inside part is 30% less dense, and there's no stackable order to the chaos in there. Several experiments have shown that crumpled sheets, even those compressed with very strong forces, only have a volume fraction of about 1/4. So, even if you got your strongest friend to smush your suitcase, you are leaving 3/4 of the space empty. Which explains why your clothes don't fit as well on the way back if you're packing them this way because you just gotta get out of the hotel.
Thank you for supporting SciShow by watching, commenting, and telling people about us. And if you got yourself a 2025 Complexly calendar, thanks for supporting SciShow that way too. Complexly calendars are all about bringing together Complexly shows in one piece of merch. They showcase Crash Course, Eons, Bizarre Beasts, Study Hall, and SciShow. The 2025 theme is a quarter century of progress, so each month celebrates something from the last 25 years that gives us hope about how far we've come and just how many possibilities lay ahead. From mRNA vaccines to expeditions aboard the International Space Station, there's a lot to celebrate. But we're only making a limited number, so get them while you can at complexly.store/calendar or the link in the description.
Much to the chagrin of laundry haters everywhere, wrinkles take up a shocking amount of space. All of that air between fabric folds really adds up. So it might be worth it to take notes from the next person. The neat as a pin folder. This person precisely folds each piece of clothing into the same dimensions, ensuring identical packing bricks. As boring as it is, neatly folding your clothes does significantly increase your volume fraction. This is because those layers of clothes are mostly flat on top of each other, eliminating the low-density spaces that plague the crumpling method. In theory, by folding carefully, your volume fraction could be very close to 1. But, of course, clothes can't be folded perfectly flat. There will always be bends that leave empty space along the crease. So in practice, the volume fraction is a little less than 1, and the more times you fold something, the more empty space you introduce. This is especially true for very thick or stiff materials. So if you're packing bulky sweaters or jeans, you're better off just folding those once. Finally, we have what I call the I saw this on CleanTok roller. This person carefully rolls their clothes into cylinders. These cylinders have similar volume fractions limitations to neat folding, but with the added benefit of a convenient shape if you're packing a duffel bag or some other container that doesn't have perfect 90-degree corners. When you're filling a rectangle, you want the stuff you're putting inside to also be rectangles, so you don't lose a bunch of space in the corners. But if your bag has flexible sides or odd corners of any kind, the math officially recommends that you roll as many of your clothes as possible. The cylindrical bricks can line curved surfaces or fit into those weird crevices made by the suitcase handle, but it matters how tight you roll the cylinders. If you got super strength and you roll your shirts really tightly, you will end up with cylinders that are hard to deform. Since its cross-section is a circle, you then are basically left packing circles into a box, which is a surprisingly difficult thing to optimize. In a 2D assessment of circles crammed into a square, the very best case scenario ends up covering about 3/4 of the space, which applied to packing leaves 1/4 of your bag totally empty. Luckily, your shirt's probably squishier than just circles in geometry. Alternatively, you can roll your shirts into less rigid cylinders, leaving a little bit of slack. This allows them to squish together until your bag's cross-section looks more like a honeycomb. In fact, bees build hexagonal honeycombs precisely because of their optimal packing properties. If the cylinders are squishy enough, you can get a volume fraction of 9/10, meaning that CleanTok has successfully life-hacked once again. So physics has spoken. Depending on what you're packing and what you're putting it in, your best strategy is either neatly folding or rolling. See? You never know when you need to fold a little bit of physics into your everyday life.